All right, part 2, let's continue. This is a division problem, so remember the riddle key. It would be x minus 6 x. Oh, we got to state the domain. Almost forgot that. X minus 6 x plus 3. We're going to change that to multiplication, so I'm going to factor this and put it in the top. So it'd be x plus 4 x plus 3. And then this guy, we're going to factor it x, that'd be 6 and 4, but the 6 has to be positive, the 4 has to be negative. So we can see that x cannot be 6 from here, and negative 6 from this one, negative 3 from that one, and positive 4 from that one. That's our domain. And now we get to start hacking out stuff, and that's it. So we're left with x plus 4 all over x minus 4. You can't keep hacking those because they're connected by addition and subtraction. So there you go. Alright, so I'm going to take a second and draw this. Okay, so the area of a rectangle represented by that craziness. So here's the formula for the area. Area is length times width. So I substituted this in for area right here. It says the length can be represented by x plus 8 right here. So I substituted for the length x plus 8. They're asking us to find the width, which is here, and there it is in our formula. So really this is just a fancy way of making you divide both sides by x plus 8. But you're not done until you're done. So this is kind of connected to this, where if you can factor things, you should. So what can we take out of here? We can take a 25x squared out. We'd be left with x plus, are you ready for it? 8, all over x plus 8. And voila. So the width would be 25x squared. And here we go, adding and subtracting. So you see adding there, adding there. We need common denoms. That's the big point. So we got x minus 1, x plus 6. So this guy needs an x plus 6. And if we do that to the bottom, we got to do it to the top. This guy is missing an x minus 1. So if you do that to the bottom, you got to do it to the top. And so this 2x hits both things. So you get 2x squared minus 2x all over x minus 1, x plus 6, plus, distribute the 3, 3x plus 18 all over x minus 1, x plus 6. Now that we have common denominators, we can add like terms in the top. 2x squared doesn't have any like terms. Negative 2x plus 3x is plus x, and then that 18 is just sitting there all by itself. All over x minus 1, x plus 6. Now you should take a second and wonder if you can factor this. So I go 2 times 18 is 36, and find 2 factors of 36 to add up to 1, and that's not going to happen. So that's as far as it goes. The domain, x cannot equal 1 from here, and x cannot equal negative 6 from here. So don't forget that little part. This guy has a little more work to do because this is factorable, so I'm going to write it x over x minus 2, x plus 2, plus 5 over x minus 2. I like to put those in parentheses. It helps me compartmentalize. So this has an x minus 2, so does this. This one has something else. So we've got to make sure we have common denominators, so we add that to this side, but then we have to do it to the top as well. So this is the only thing that's going to change. So we distribute, we get 5x plus 10 all over x minus 2, x plus 2, and as you can see, we got common denominators, so we can add the stuff in the top. X plus 5x, 6x plus 10 all over x minus 2, x plus 2. So you wonder, is this thing done? Well, we can factor a 2 out of there, so we'd be left with 3x plus 5. So you can see that that's not going to cancel. So the question is, which answer do you want? I would say this one, because if you get into the habit of doing that, then you're always checking for further Hector opportunities. But truly, these are both correct in this situation. And now we've solved. So my new jingle is equals eliminate. So here we have to find common denominators, equals eliminate. So if we have x plus 4 there, that's what we need to eliminate. Remember that 6 is over 1. So we're going to multiply by x plus 4. Why? When this hits this, these cancel. So I'm left with 18. But then when this hits this, nothing cancels, so I have to distribute 6x plus 24. Now it's pretty simple looking. So negative 6 equals 6x, divide by 6, and I get x is negative 1. But at the very beginning, we should have said x cannot equal negative 4. But that's not what we ended up getting, so we don't need to worry about it. That's our answer. Again, equals means eliminate. So I'm going to put that in parentheses, and I'm going to multiply this side by x minus 1 and this side by x minus 1. So when this hits this, they cancel. Just left with 9. When this hits this, nothing cancels, so you distribute 3x minus 3. So I'm going to add 3, and I get 12 equals 3x. Divide by 3, and I get x is 4. From the very beginning, x cannot equal 1. But that's not a problem because we didn't get that. So there are no extraneous solutions. This guy, we got an x and we have a 3. So we need to think, all right, I want that to disappear and I want that to disappear, so I have to multiply by both of them. When this hits this, I get 24x. When this hits this, the x's cancel. 3 is still there, so 3 times 2 is 6. And then I'll put a 3x over here because that's getting kind of messy. But when this hits this, the 3's cancel. I have x times, I'm going to add up. X times negative 4 is negative 4x. So after all that work, it kind of cleans up nice for us. And we get 6 is 28x divided by 28. Reduce it, we get 3/14 equals x. Now from this one, the only thing x could not equal is 0. So we'd have to kind of make that mental note there. And so there we have it. This guy, x plus 3, don't like it, don't like it, let's eliminate it. So we're going to multiply this side by x plus 3, and we're going to multiply this side by x plus 3. So when this hits this, these cancel. We're left with 2x, kind of nice. But when this hits the 5, nothing cancels, so we distribute it through, we get 5x plus 15. But then when this hits this, these cancel, left with plus 6x. I'm going to state it right now before I forget. X cannot equal negative 3. So that's our possible extraneous solution. So I'm going to subtract 2x, subtract 15 from both sides. So these go bye-bye, these go bye-bye. Negative 15 equals 5x, and 6x is 11x. 11x minus 2x is 9x. Divide by 9, and x is, 3 goes into both these, so negative 5/3. So we don't have any extraneous solutions yet. Alright, almost done. Again, all we're going to concentrate on is getting rid of these weird denominators. So we're going to multiply. You got an x minus 8, x minus 8. You got to multiply everything by x minus 8. So this times this, they cancel. So we're left with x squared, which is a little bit of an oh no, because you're going to have a trinomial you're going to have to deal with probably. But when this hits this, they also cancel. So we're left with 64. But then when this hits this, nothing cancels because we have a 1 down here. So the negative 8 actually distributes its way. So you need to see something like this. So distribute, distribute. We get negative 8x plus 64. So when you have a trinomial, you want to set this equal to 0, keep your x squared term positive, and then factor it. And then you solve it. That's essentially what you do. So we're going to realize that this is negative 8x plus 128 equals x squared. So we're going to subtract 128, add 8x, because I'm keeping this positive. And this gets a little weird. They're giving you a very strange trinomial because you haven't dealt with many of these. But 8x minus 128. So we need to figure out two factors of negative 128 that adds up to 8. And 64 and 2 jump into my head, but you can see there's no way we're going to make an 8. So I'm going to go 32 and 4. No way we're going to make an 8. 16 and 8. There's our magic combo. So we're going to go x, x. You could shove all of this into the quadratic formula and you'll get your answer, but that'd be kind of a nightmare, but I guess a calculator. So if you did that, a is 1, b is 8, c is negative 128, and you could use this if you just hate factoring. So there's your go-to if you don't like factoring. But I need a positive 8x, so that's plus 16 and minus 8. So my answers for x are negative 16 and 8. But wait, you can see from the very beginning, and I should have said it right away, x cannot equal 8, because that would cause a 0 down there and there. So this is an extraneous solution right there. So we're going to move on to 25. We're almost done. Don't forget to factor if you can. X minus 3, x plus 3. I'm going to rewrite this. X minus 3, x plus 3. Give myself some space here. 3 over 6 times x minus 3. Don't distribute this through. That's just going to cause nightmares. We have a 6 here. So, what I'm going to do, we have an x minus 3 and an x minus 3, so we got to multiply by one of those. We have an x plus 3 here, and we don't have one here, but we want to get rid of it, so we have to multiply by it. And then we have that 6. So all three of these things has to hit all of this and this. So what happens when this hits this? The x plus 3's and the x minus 3's disappear. And then 6 times 9 is 54. That cleans up real nice. But when all of this hits this, I'm going to use a marker here. The 6 disappears, the x minus 3 and the x minus 3. So really the only thing left is the x plus 3. And that has to hit the 3. So that's 3 times x plus 3. Distribute, distribute. 3x plus 9. So I'm going to subtract 9. And I get 20, whoopsie, I get 45 equals 3x, divide by 3, and I get x is 15. Now, up here, x cannot equal 3. From here, x cannot equal negative 3. And there you have it. I do want to throw this out there. If you have 4 over x times x plus 2, I'm just making this up, something like this, your domain, x can't equal negative 2. A lot of students don't look at this because x cannot equal 0 either. And there's nothing like this in your review, but I'm wondering if that pops up on your test or not. So be aware of that. If there's a singular x sitting there, you can't ignore it. X can't equal 0, because if you put a 0 in there, then that would be 0 times 2. That causes 0. So explain how to check to see if the solution is to a rational equation is extraneous. Well, we just did it. We got an 8 for one of our answers, which is not possible, and that's how it becomes extraneous. And that'll do it.